If we take a look at this black section, we're going to take a look at the relationship between sine and cosine in a right triangle. Okay? So we're going to use this triangle to fill out the following table. Okay? Well, we're going to find the cosine of x. So we're going to start out our angle. So across, we will label that as our what? Opposite. Go to your 90, go across, we will label this as our hypotenuse. And the guy left over is always just our adjacent. So if we want to find the sine of x, how do we set up that ratio? Well, to figure that out, what should you have written at the top of your paper? Okay, so go ahead and write that. Okay, so well, how are we going to set up the ratio for sine? What over what? Opposite over the hypotenuse. So what would that fraction look like? What's our opposite? 3. What's our hypotenuse? Well, as we always do with fractions, we're solving. We just want to, what do we always have to do with fractions? Simplify. Can we simplify 3 over 5? Nope. Just leave it. We're going to skip this square for right now so we don't have to relabel everything. We're going to find a cosine of x. Well, if we're trying to set the cosine of an angle, how do we set that up? Cosine is what over what? Yeah, adjacent over hypotenuse. Well, what's our adjacent? 4. What's our hypotenuse again? And does that fraction simplify? Nope. Now we're going to go to angle y. We have to relabel some stuff. It's really nice because does our hypotenuse change at all? No, it's going to stay the same. But now we're taking a look at y. So when we relabel, we go across from our angle. That's our opposite. That's going to stay our hypotenuse, and this guy's our adjacent. So when you switch angles of the same triangle, the opposite and the adjacent just kind of flip-flop. Okay. So now when we find the sine of y, what's that going to look like? Sine is opposite over hypotenuse. Again, what's our opposite? 4. What's our hypotenuse? 5. That fraction simplified? Oh. So now let's find the cosine. How do we set up the cosine of y? What's that look like? 3 over 5. Adjacent over the hypotenuse. So 3 over 5. What are you noticing? What can you conclude based off what we got in our table? Do you notice anything, Alexia? Yeah, well, you would have to word that a little bit better. Sine of x is the same as cosine of y. Yeah. Sine of x is the same as cosine of y. So let's fix this. There's flip-flop. So then what do we know about the sine of y? Sine of y is same as cosine of x. This is true for every single right triangle. Your cosine of one angle will be the same as the sine of the other. Or the sine of one angle will be the same as the cosine of the other. They will equal. So if we say the sine of x equals 0.57, what's the cosine of y going to equal? 0.57. They're going to be the same. The sine of one angle will be the the cosine of the other angle. They are exactly the same. So whatever the one angle is, the other one's just going to be the same thing. The sine of one is the same as the cosine of the other. Cosine of one is the same as the sine of the other. Every single time in a right triangle. Okay. Questions over that? So we can fill this in. So from this, we can conclude that if x and y are the measurements of complementary angles. What does complementary mean? Add to what? Not 180, you're very close. Add to? Supplementary is add to 180, complementary is add to 90.
Complement your bicep.
Well, we know that these angles add to 90 degrees because what do all three angles of a triangle add up to? This guy plus this guy plus this guy would equal what? 180. So we know if we add up all three of these angles, we know we're going to get 180. Well, if we remove the 90-degree angle from this equation, if we remove it, 180 minus 90 is 90. So we know these two other leftover angles are always going to add to 90. So if x is 30 degrees, what's y going to be? 60. These two will always add to 90 degrees every single time. And their sine of the one angle is always going to equal the cosine of the other angle every single time. And again, we can say that if we have x and y and they're complementary, meaning they add to 90, we can say that the sine of the one angle is equal to the cosine of the other angle, and vice versa. We also know that this and this add to 90 degrees. Because when you take the sine and cosine of something, you're always taking the sine and cosine of an angle. Right? So we know that angles also add to 90. And that's what we're saying here. That if we have 90 minus an angle, then we know that's going to equal the cosine of that angle. And theta, that's just a variable. It's like saying x. So if it's more helpful, replace this with an x. So we can say if we have 90 minus some angle, that will be the same as the sine of that angle. Because we know those two angles add to 90 degrees. That's what we can use here. Right? Again, when you're taking a sine or a cosine of something, okay, we're going to assume that these angles are the acute angles of your right triangle. Okay? Whenever you're taking the sine or cosine of something, of an angle. So this is one angle, this is another angle. And they're angles that are in the same right triangle. So what do we know about those values? What did we say they added to what? They added to 90. So you just have to take the one angle plus the other angle, and that will equal 90 degrees. Well, how are we going to find x? Subtract it. So x is equal to what? 5. So what we just found, let's say we had this right triangle. We just found that we knew that one of the angles was 25. We just found that the other angle was 65. These all three add to 180. So a shortcut of that, if you just have a variable and a number, what would the shortcut be? What could we have just done with 25 right off the bat? Subtract it. It's pretty much what you're doing here. That shortcut, well, again, how can we figure out what x is? What can we just do? Subtract this from 90. So take that angle, subtract it from 90, and that gives you that other angle. It's 90 minus 80. 10. Because we knew these are angles of the same right triangle. That's 90. One of the angles is 80. What does that other angle have to be? 10. 80 plus 10 plus 90 gives you 180. That's pretty much all you're doing. You're just trying to figure out that other angle in the triangle. Questions over there? Same thing with this one. What you're taking the sine and cosine of, that's one angle of your right triangle, that's another angle of your right triangle. And what do we know about those two angles? What do they add to? And what? Yeah. What do they add to? A little louder? 90. Thank you. So what? How do we set this up to figure out what x is? What did you write on your paper? Yeah. All you have to do is just take those values when they both have variables and just add them together, set them equal to 90, and solve. The previous ones, there was only one variable, so you can just subtract it from 90. And then solve. Well, combine your like terms. X plus x is 2x. And now just your basic bear problem. How are we going to get x by itself? 10. And then what do we have to do with the 2? Divide by 2. So x ends up equaling what? 40. Good. So again, we just found this angle. X is representing an angle in this right triangle. We know one of them's 90. We found that one of them is 40. So without really having to do much math, what do we know the other one has to be? What does the other angle have to be?
Remember what it has to equal.
What do they add to? It has to be 50. Yeah. Because we know these add to 90, so if you want to find that one angle, you can just subtract it from 90 and you automatically have the other angle. You also could have taken 40 and plugged it in. A little more math. Or you just take your value, subtract it from 90, and you have your angle. Questions over there? And really similar for 4. How would we set this up if we're trying to find x? What do we have to do? How do we set this up? We know about these two angles. What do they add to? Or what do these angles add to? How do we set this up? 90. So what would it look like when we write it on our paper? Sydney? And then you just solve. Again, what's our first step when solving? What are we going to do here? Combine the like terms to get 2x. And then how are we going to get x by itself? Good. We get 135, and then what do we have to do with the 2? So x ends up equaling what? 67.5. So again, that's representing one of your angles. So this angle 67.5, what does that other angle have to be? 3.5. 22.5. You just take that value, subtract it from 90, you have the other angle in that triangle. Questions over that?
Angles equal 90.
Every single time. info. Make sure you make these changes in your notes. This guy, this should be a plus sign, and there should be a decimal point in front of that 8. So it's actually saying the sine of r is equal to 5x plus 0.80. Make sure you make that change.
So everyone should be correcting this right now. Sine of r equals 5x plus 0.80.
And this should also be a plus with a point in front of the 2.8. So that's actually saying the cosine of t is equal to 10x plus 2.8. And good change. Okay. So in a right triangle, RST, angle S is a right angle. The sine of R is equal to 5x plus 0.80, and the cosine of t is equal to 10x plus 0.28. Okay. Well, we have a right triangle. We know S is the right angle, so we know R and T are the other little angles in your triangle. What's a little bit different about this problem than the ones we did on the front? Where were the variables on the ones on the front? X and Y, and where were they located? What's different? Here we have the sine of R equals something. Here we have the sine of an equation. Okay? So we weren't given the equation for the variable. We were given the equation of what their sine is and what their cosine of those angles are. Okay? So we flip back to what we talked about before. We said that the sine and their cosines of the different angles were the same. So the sine of one angle is the same as the cosine of the other. So here, in this example, we're saying the sine of one angle is 5x plus 0.80, and the cosine of the other angle is 10x plus 2.8. Well, what do we know about those two things? They're the same. The sine of one angle is equal to the cosine of the other. So what can we do with these values? We know they're the same. Set it equal. So that was a little different. So on these examples, we were given an equation for the angle. Whenever you're taking the sine of something, that something is an angle. So when you have the angles, you just add them up and set them equal to 90. So think when they're inside a parenthesis or they're connected with the sine or the cosine, you add them and set them equal to 90. When they're not connected to it, when it's the sine or the cosine equaling those values, you set them equal to each other. So the sine of one angle is the same as the cosine of the other. And then you just solve. Well, how would we solve this one? How do we solve this one? What's our first step? Basic, normal solve an equation. What would we do? There, what do we do? Multiply that. You know, basic their problem with their next step. How do you x by itself? How do you get x by itself? Subtract 0.28. What is 0.80 minus 0.28? 0.52. And then what do we have to do with the 5? Subtract. And I know we're messing with dealing with goofy decimals. That's okay. What's 0.52 divided by 5? Point what? 0.104. Because if you notice, when you find the sine of an angle or the cosine of an angle, you took like the sine of 15 or the sine of 22, something like that, it spits out this really long, nasty, ugly decimal. You'll also notice that the decimal is less than 1. So if you have a problem like this and your answer is more than 1, something went wrong. Okay? Question.
So again, you'll see one like this here in a little bit. Whenever you have the angles, this, look at this, we're not giving the angles, we're saying R, we're saying T, those are angles. Whatever's beside that trig, either cosine, sine, or tangent, whatever's beside there are the angles. So if you have a value for those, X or whatever, you're going to add those up, set them equal to 1, angle or 90. Angles equal 90. If you don't have those, you're just going to set them equal to one another, because you know the cosine of that angle is the same thing as the sine of the other end. Recognize whether you have the angle or you don't have the angle. That's it.
Questions over there? One more. We are given that the sine of 6x plus 15 is equal to the cosine of 3x plus 30. Find x of the values of the angles in the corresponding right triangle. Well, we have stuff inside the parentheses. So we have equations for the angles. What do we know about these angles? They're in the same right triangle. What do we know about them? What do they add to? Well, what are the ones on the front add to? 90. Do this again. Take these values and add them up and set them equal to 90.
Notice they're sitting right beside sine and cosine in this scenario. They're not equal to something. Another angle there. Those are the angles.
And then solve. So when we solve, again, what's our first step? If they're on the same side, gotta be careful, use the same signs. So we're just gonna, you're right, we're gonna combine them, make sure you keep those signs the same.
Push them together first.
So then 6x plus 3x is 9x. 15 plus 30 is 45. Now you're down to your basic pair. What do we have to do with 45? Get x by itself. Subtract it. And then what do we have to do with the 9? So x ends up equaling what? 5. Here's the thing, we found x. We need to find the measures of the angles. Well, how are we going to do that? Before we can subtract from 90, you notice our angles, one angle is 6x plus 15, the other angle is 3x plus 30. So what do we have to do before we can subtract from 90? Plug it in. And it doesn't matter, pick one. Which one do we want to plug it into? The first one or the second one? First one. Doesn't matter, just pick one. So we're going to take 5, plug it in that first one. We're going to say 6 times 5 plus 15. You don't need to include the sign, but we're not trying to find the sign of the angle. We're just trying to find the angle. So you just ignore whatever's there and plug it in x. And what's 6 times 5 plus 15? 45. So you just found one of the small angles in your triangle. Well, how are you going to find the other small angle? It's 45. Because remember, you just take the value and subtract it from 90. So once you get one of the angles, you just subtract it from 90 and you get the other. This has to be nice. So one's 45, the other one has to be 45. 45, 45, 90.
Oh, you've seen that before. That repeats itself.
You could, if you didn't recognize it, take 5, plug it into the other one, but you're going to get 45. Questions over that? The rest of the time,